My name is Shannon Appelkline, and I'm a writer generally, a technical writer for Blockchain Commons. And today we're going to talk about interoperability. We're going to have some kind of lessons learned and our general thoughts on why we think it's important. And then we're going to have some more general discussion about what problems people are having. So this is the presentation, Interop, what's it good for? Uh, Here we have our kind of general text on Blockchain Commons, which we've published any number of times in any number of presentations. But what I wanted to particularly point out here is the start, which says we're a community that brings together stakeholders to collaboratively build open and interoperable, secure, and compassionate infrastructure. So there's interoperability right there in our kind of core goal. It's one of the strongest things that we focus on at Blockchain Commons. So why? Here's a quick definition of interoperate: to work in conjunction with each other. Seems pretty simple. And of course, we're all meeting here through the internet, which is built fundamentally on interoperability. We have protocols through any number of organizations that make sure that our packets of communication actually get to each other. But one of the problems that we see with interoperability is that yes, we're pretty good in the 21st century at creating interoperable communication, but we're not necessarily great about interoperating other things, and those other things become very important too. So I thought mail was a great example because it's something that I've had system administration experience with for 30 years and have gotten more and more frustrated with over the years. We talk about the communication level, and that's pretty well understood. We do use DNS, which lets us look up the names of who we're mailing to. We use TCP/IP to connect to those other machines, and we use SMTP to actually exchange the mail. All great. Things communicate pretty well. There's older protocols like UUCP as well. It all worked great. But when you start digging down from there and going beyond just the communication, the interoperability gets worse and worse and worse. Uh, to use the example of mail, you look at storage, and fundamentally there are two main ways that mail is stored, which is either in a single file, it's an inbox, or in a bunch of files, that's EML. But Microsoft, of course, has its own protocol, which is MSG. I'm sure there's others as well. I used to store my mail in the 90s in a command line program called MH, which had lots of different files that I do not believe were EML. And I eventually just had to give up on ever getting those off of the machine because I probably could have, but it was a huge pain in the neck. Um, you step down another level and you get to filtering, where you start having protocols for mail not necessarily getting to someone theoretically because it's spam or uh, something else, maybe even harmful to the user. And again, there are some protocols to try and support getting mail through this filtering: DKIM, DMARC, SPF. There are various ways to say, hey, we're the real source of this. Hey, here's a signature, etc. But over the last 10 or 15 years, it's been increasingly frustrating to get mail to the large providers, Gmail and Hotmail in particular, even if you're obeying all of these. And this can be as simple as the users marking them as spam, even though it's mail they requested, and that affects their algorithm. The thing that results from this, though, is that my mail does not get to you, even when it's mail that you've requested. And that's an interop failure. And it's a really important one because it doesn't matter that this communication works. It doesn't matter that things might be stored in a interoperable way. If you can't get my mail, all the rest is worthless. And that's where our first lesson learned came in. Uh, I've got these kind of throughout this, they're kind of blithe, but any gap in interoperability endangers all interoperability. And that's one of the reasons that we think it's so important, and important not just for the communication that's already understood on the internet. There's other reasons we think it's important too, and a lot of these go back to our Gordian principles, which are uh, the main things we look at when we're evaluating, assessing, and architecting systems. We have four of them: independence, privacy, resilience, and openness. And I could probably come up with some reasons how privacy is related to interoperability, but I wanted to focus on the other three, which are independence, resilience, and openness. And I feel like each of these mainly affects a different category of things in interoperability. So independence, we feel like that's mainly for the users. Uh, Christopher wrote 7 or 8 years ago now, something called A Path to Self-Sovereign Identity, which probably many of you are familiar with, which was the first real look at how can you have digital identities that are controlled by the user, not by some corporation, organization, etc. And that was all about independence. We want users to be able to do what they want, use the applications they want, use the services that they want, and move among them without losing their data, their footprint, their identity. Uh, and so that's the first place that interoperability becomes important because if we have an interoperable, say, storage system, then you could move your data from one system to another. That's something I could have used when I was trying to get my MH mail to uh, other email systems 20 years ago. We don't want users to be locked into a single platform. We want them to have the choice. And for some reasons I'm going to talk about in a second, that can make the whole ecosystem better when they have that choice to choose the best service. So resilience is the second one, and resilience, we think that that protects data. Uh, that interoperability protects data for resilience. When you have interoperable data formats, you have data that's well known, that's well understood, and hopefully well documented, which means that if someone comes along in 20 or 30 years and says, hey, I need to recover that information, they can. That's obviously really, really important for things like keys and seeds, where someone really could be coming along in 20 or 30 years, or in many cases, someone's heirs may be coming along to try and recover what could be a digital fortune. Uh, as a amateur historian, I do a lot of work trying to get old source materials. Some of them are clearly in books, but I have a lot that I've worked with over the years that were in various data files. And some of them, ClarisWorks, PageMaker, WordStar, which I mentioned here, they're really, really hard to migrate. And even when I can find a tool that someone's made, it often doesn't do it well. And again, if we would look at something like keys or seeds, if you have something that kind of converts things like the ClarisWorks things I've seen, you're going to lose the data because every single bit matters. So that's why interoperability is important for resilience. And the last one is openness. And here we think it interoperability really helps the creators, by which we mean the people that are building applications and services. And the reason for that is because it lets new people into the ecosystem. If there's an interoperable standard or specification for something, then it's really easy to just come into the system and, offer your innovations and say, hey, this is why my program, my application, my service is better than anything anyone else is doing. And that's where interoperability can improve the whole ecosystem because you're getting not just the same old stuff, but new ideas from new people. It creates co-opetition, which is cooperative competition. And that's the next little insight I had. Oh, not quite yet. Um, interoperability openness is also important for the user. So this is one where it isn't just affecting one person, but it's affecting everyone. And the reason is without the openness, then you have the NASCAR problem, which we can see at the right, where you try and sign into a service and it gives you this huge list of different methodologies. You could use Amazon, Apple, Facebook, GitHub, et cetera, et cetera. It's really bad for users. It's horrible accessibility. It also makes it harder to do meaningful automation, which is something that we've focused on with Guardian Envelope and the GSTP system that Wolf talked about a little bit earlier. Um, there's an article there about how OpenID failed and has led to this interoperable problem, which is where I pulled this graphic from. All right, so a little insight. Uh, when you have an interoperable ecosystem, everyone can cooperate, but they only cooperate to interoperate. They then actually compete to be the person with the best product. And so it doesn't undercut competition itself. It just supports it and raises it up and means you're competing on important things, not just, file formats and data formats. So Blockchain Commons, over its several year history, has mainly focused on things to support the Bitcoin ecosystem. And we've had three really big successes among this: URs, animated QRs, and SSKRs. I think we're on the verge of adding envelopes to this list as it's been seeing more uh, adapt adoption. But for the minute, I want to talk about these three fundamentals. So UFRs are uniform resources, and they're a pretty typical interop method in that they are about communication and storage. They're just CBOR encoding methods. CBOR is our binary format that we use to represent most of our data. Clearly, a binary format isn't great for transmitting and stuff, so we make these URs, which add a little self-identifying bit onto the front, and they add a little checksum onto the back, and they put it all in ASCII characters. And so it's easy to see what it is, it's easy to know what it is into the far future, and it's easy to make sure that it is not corrupted. And the big advantage that we got from URs is that they were specifically built to support QRs. Um, their encoding is efficient, and they're set up in such a way, and we have some documents that describe this, so that you can actually create multi-frame animated QRs. And that was a really big thing for the ecosystem because we'd seen problems where people could not transmit data using air gaps because it was too big. Air gaps are very important because they're a very secure way of transmitting without having to worry as much about some of the attacks that happen when you have live connections. Um, but we were starting to get PSBTs, partially signed Bitcoin transactions, uh, where you would make the transaction on a network computer. You'd want to send it to a hardware wallet or another device for the signature, and then send it back to make the security the best you could. But the PSBTs were too big for a simple QR. So we used URs, we built them into animated QRs, we offered that as a way to get these PSBTs back and forth between air gap devices, and that was our first really big success as an interop. And one of the reasons was because there was a really big demand for it, um, which we'll get back to. So the other one was SSKRs. As I said, URs, they're kind of mostly communication, especially as they're used with animated QRs. But SSKRs are something totally different. They're a way to uh, divide a seed and to securely store it so that you can get it back in the future. You can get back if you lose your own device by pulling in the shares from different people. And Shamir's secret sharing has been a well-known way to do this for a long time, but we'd often seen problems with people misimplementing it, which obviously is disastrous when you're talking about seeds. So we wanted to offer a secure and reliable methodology for it, a library for it. And we also wanted to build it in such a way that it could use our URs so that they could easily be sent around, and also so that we could in the future plug in other secret sharing methods. VSS has been one of the ones that we have been thinking about adding for quite some time, but the idea is that SSKR can offer a standard API and a way to deal with all of these. So clearly this is very different from just straight up interop communication. And the question is, why is the interop important here for a storage method? And there's two things that we think are really important here. One's the one that I talked about several times here, which is just recovery. If these shares of seeds are stored as SSKRs, then they can easily be recovered far into the future because it's a reliable, well-known format. Uh, but the other thing is it allows for collaborative seed recovery, which is kind of what led us to start having these Guardian meetings in the first time. Um, we want to create a system where there are independent share servers who will hold shares for you. You can have a device that breaks up your seed, sends it off to these share servers that you have individually chosen, uh, and then recover them at some time in the future. It's a much better method than, giving your shares to your mom, holding them in a book, whatever. And by having an interop, then we can actually communicate these shares using GSTP. So those are, I think, some good examples of how interop can go beyond just straight up communication. And when it supports other things, it can be really useful. So Ken is here from Foundation, and we've worked with them for a long time. They've adopted a lot of our specs. I think this listing is accurate. URs, animate QRs, SSKR, envelope request response, GSTP. Um, and one of the reasons that we love working with Foundation is because they've adopted so many of our specs, we can see how they start to have a multiplicative effect that the more interop specs that get adopted, the more powerful they all become, and the more that they allow the uh, people using them to focus instead on the things that are really important to them and not these foundational intercommunication and storage methods. So their Passport Prime has something called Quantum Link, which is secure quantum resistant Bluetooth communication. It allows them to do easy updates and transmit big data around. And one of the reasons we think they were able to do that is because they have so many of these specs that they could focus on something really important like post-quantum computing. And of course, we supported them in this and helped them get that post-quantum computing in. And now that's available to other people too. So thanks, Ken. We're really happy to be working with you so often. So our newest work has been with Zcash. Like I said, we've long worked with Bitcoin, but for the last several months, we've been working in addition with Zcash. And they had a very simple problem, which was that they needed to deprecate their classic Zcash D server. And the problem with that was that there was wallet data associated with Zcash D servers, and they needed to be able to migrate that. So it probably would have been relatively easy to just build a simple migration tool that said, hey, if you have a Zcash D wallet, you can move it into Zalet, a newer wallet that we're offering. But we talked to them and they saw the bigger picture, which is what if we took this as an opportunity not just to, do this one little thing that has to be done right now, but to create a whole interoperable ecosystem where any wallets who adopt a new format that we create uh, can exchange data. It makes it so that users don't get locked into those individual wallets, and it also hopefully helps to get around some problems where in the past users have lost data because of, slight differences in the way different wallets worked. And of course, as usual, it can keep data safe into the far future. Thing is, can be very complex. So Wolf put together this diagram showing exactly how ZWIF, which is our Zcash extensible wallet interchange format, works. And you can see right in the middle, we have the in-memory structures. That's kind of the heart of it, which is the way that we store this interchangeable data. But we have to be able to support it coming in from a lot of different wallets. We have to support it going out to a lot of different wallets. And also, we needed our own Gordian envelope-based file format, which is the ZWIF interchange format. So you can see that there can be a lot of complexity in the interoperability, but it can create all the advantages that we've seen. And I think this is one of the biggest advantages that we've kind of learned along the way, which is interop can be really invisible, but without it, things just don't work. And users may not notice it's there, but they notice if it's not there. Okay, so why should you interoperate if you're an ecosystem? If you're not the market leader, we feel like it's pretty obvious. It gives you an in, it gives you a way into a market. But we hope the people that are the market leaders are going to be interoperating too because it's beneficial for their users. And it's also beneficial for their data because it makes it possible to recover it. So, what's the most important interoperable element? That we have definitely learned through our work with Zcash and with Bitcoin before that, it's the community. The community is the one with the expertise. They understand deployment. They can test interoperable specifications. It's ultimately only the community that will make an interoperable spec a success. And so that's always been one of our fundamental rules. We work with the community in meetings like this. So that just kind of reiterates that because we think it's so important that without that community buy-in, an interoperable specification will fail. So how do we do the interoperable work? It kind of goes back to what I just said there. We identify a need. It was like with animated QRs, our need was to get those large data files around. If you don't have a need, then the specification is not going to be relevant. With Guardian envelope, the need that we saw was to be able to minimize data. Um, Once we've identified that need, we architect to meet those needs. But then that's where the community comes in. We start iterating. We talk with the community, we produce a specification, we revise the specification, we talk to the community, etc. And that's where we are with Zcash right now. Wolf did a few months of initial work, but Chris and others are helping us now to make sure that that actually is exactly what the community needs so it can be used well into the future. So that's largely what we have today, just kind of on the general. We are looking to extend the work that we have done, particularly the Zcash work we've been doing over the last few months to other ecosystems. Uh, and we would love to work with people who have upcoming conversions or transitions like Zcash D, who just want a wallet interchange format, who want to exchange seeds or shares, or just do anything that will be improved by interoperability. If you are interested, you should talk to us at the email there. And we wrote an article which paralleled some of what was in this presentation. If you want to look at it, it's right there. It's linked pretty prominently from our homepage and from that QR. And that's it for me today. Chris, any questions? All right. Chris, you want to take over the meeting from here?
Yeah. Um, so one thing we didn't talk about was, um, the importance of not just the portability, resilience, and all that kind of stuff, but what happens with the all of these different lack of interoperability places. These all become um, snares that people can use for centralization, and centralization can impede competition because you're basically using some uh, trivial particular place, locking people into that particular place in such a fashion that they can't exit. And then the consequence is you don't have to be innovative anymore. So uh, you're not offering a service to users. And so that can work for a few years, but at some point, inevitably, there is a collapse and, like with, Windows 98 and things of that nature, um, there comes a point where, hey, I can't do this anymore. I just have to, break and move to another platform. Um, the uh, so we want solutions that um, you know eliminate as much as possible these kind of lock-in points. Um, Now you can, as a, if you're an incumbent, you can go, oh, wait a second, I like my lock-in points. I need those. I need those to get my VCs. I need those um, to, continue to make money. And I say, well, yes, but that's a short-term solution because as you're going to be routed around in the future if you don't. So, um, uh, I was, hoping that we could maybe have a little bit of a discussion about, how as an ecosystem, we basically from the demand side say, hey, we have to have interoperability, or else I'm just not going to, purchase your product. And, how do we support those types of things? Maybe Mike might be able to say something also in regards to kind of the other kind of open wallet initiatives, there are a variety of other places you can go to build standards and such. Um, but I think oftentimes they are driven by the centralized parties who then want to, lock in their particular approach to things, So we're sort of seeing this with some of the emerging identity wallets where, Apple and Google are basically saying, well, you have to use our hardware, so you have to do it our way. Um, any thoughts or discussion on that?
I would just say that, from the beginning, Foundation was founded, no pun intended, with that exact goal is that we wanted to be the open source standard that everybody could use. And that was why we started adopting the UR format. There's still an issue with wallet formats, like you suggested. This ZWIF. There's no similar format like that for Bitcoin, which is really unfortunate. Which means that in our apps now we have these big lists of all these different wallets that we support when you want to import or export things, and each one of them has like a slightly different format, and it's incredibly annoying. And we're relying right now on BDK for a lot of our Bitcoin functionality, and we'd love to at some point in the future see some sort of wallet interchange format built into BDK where we can import and export wallets and other things. But our whole purpose of existing was to make that make Passport accessible to every software wallet out there. And so we've just had to do a bunch of work to make that happen rather than relying on a standard format.
Yeah. I mean, we're seeing with Bitcoin D, there is basically a transitioning happening from moving from the old SQLite database legacy. They're also having to advance forward. And I think that the goal is later this year or next year that they're going to start deprecating the Berkeley DB. That's what it is. The Berkeley DB parts of the legacy wallet, and only allowing you to import them from old versions of Bitcoin D. But they have some similar problems. You really can't bring Bitcoin D data into any of the other wallets because Bitcoin D isn't really seed based at all. It generates HD keys, but it does not use seeds to do so. So, how do we support people to be able to have the resilience and reliability that they need for their digital assets? So it's sort of, and, I mean, so I've been, involved in the identity community for, a decade now. And, one of the challenges that I'm seeing there is that, there hasn't really been an emphasis on the layer zero. It's like, it's okay if a browser stores the key somewhere in its browser database. And, it's so the more innovative efforts have been happening on the cryptocurrency wallet side, where they're basically going, no, you can't trust the browser for this. You really have to have something stronger. Um, is Mike, are you seeing any movement toward the being able to do things more securely and more attention paid at the layer zero?
That's a good question, and I'm going to give a very vague and fuzzy answer because and I'm going to do so to sort of highlight the moment relative to sort of a decadal change. Economic systems sort of evolve slowly, and then quickly, right? And we have a new administration with new priorities, and I think we're all habituated to this sort of a kind of adversarial model, like crypto versus TradFi, right? Even the term TradFi is not very polite. It doesn't sound nice, right? But I think when we look back, if someone watches this video 10 years from now, we're going to seem to be in what would be equivalent to kind of like the wildcat currency era of the United States when, um, everyone had their own standard, right? Everyone had banknotes. Every bank had their own banknote. And I think the work you guys are doing here is part of a trend where even DeFi is a kind of variant of federated. And when you finally get to sort of open, that's when the magic really happens, right? And it's in that theme of interoperability. So I think as a rule of thumb, over the next decade, and again, these things never move as quickly as you'd like to see, the open will win, and uh, interoperability will win, to some of the points made in the great presentation.
Thank you. Another factor that we didn't really talk about is, the emerging need for data minimization, least authority, all of these types of things that have been designed into our architecture. But at this point, we're not really seeing as much demand as we would like to see for it. One of the things that, for instance, with the ZWIF format, there's, once it's actually, fully deployed, and we've got a couple of wallets that are successfully using it, there is sort of the next stage of being able to say, okay, well, now I need to extract, an elided version of this data to give to my CPA. Because there's a lot of private data in a Zcash wallet that exists nowhere else, but if you want to do proper tax reporting and things of that nature, you need to be able to give it to somebody to be able to do so. And I think that's, an emergent problem as, we're trying to do the right things with cryptocurrency. And, how do we do so with safety? And still have resilience, which I think is subtly different than safety. I mean, there's this whole thing of, there's one thing which is protecting against collusion. There's protecting against single points of failure and things of that nature. But then there's this kind of robustness side of things, which is, I think, an important aspect of this that we need to be thinking about.
I think a lot of that applies particularly to identity work, which we haven't been doing as much work on, but the data minimization, there's just so many points of possible discrimination in identity that that's somewhere we'd really like to see people saying, hey, that's really important to us.
Chris, you've been working with us lately on the ZWIF format, and especially in the sort of the community involvement. I think we would say in our postmortem of what we've done so far, and there's still quite a bit to do, that where the lines are vague. We had a discussion, for instance, oh, well, addresses sometimes don't have keys associated with them. And maybe we should have derived addresses separately from from addresses that we got from other sources, rather than kind of putting them in the same bucket. They should have been in different buckets. I don't know, but things like that. And then there's sort of the future proofing side of things, which I think you've been working really hard on, which is you're much more aware of, like, what may next year's Zcash be needing to do, which means this structure maybe should not be broken into pieces. That we need to keep that structure and that data intact. You want to say anything about that, and any lessons for other communities that are wanting to do interop?
Yeah, absolutely. I mean, I think that the biggest takeaway from this, and sort of the thing that I wish that we had thought about early, is that when you're considering an interop format, it needs to be essentially designed with interop as the primary goal, as opposed to, say, replicating data structures that may already exist in other contexts. Because with an interop format, you really want something that is going to have at least some long-term stability, but also evolution of these formats is really important because, or I would say versioning of these formats is really important so that when you go to import some data, based upon the version of the format exactly what the semantics of the data that you're importing are. Um, and so those are the things that I would say you should really, keep top of mind at the outset of is, how this format presumably, someone's going to take and stick a wallet backup into, onto a thumb drive or whatever and put it in a safe and then want to be able to do something with it 5 years down the road. Whatever software they're dealing with that 5 years down the road needs to be able to know exactly what the data in that interchange format means. So that's kind of you know the feedback I give. And in terms of the thing that you discussed with respect to what we're doing with Zcash specifically, um, in Zcash, we're a specification first community. Um, Everything is heavily specified in our protocol spec and the zip process. And when there is a canonical serialization of a type, we also are always heavily focused on exactly that question of recoverability, versioning, formats being able to be identified by future parsers. And so there's sort of a fine tuning in terms of we don't want to reproduce all of that work that goes into canonical encoding and versioning in an interchange format because it's already so well specified, and it's in integration libraries. We already take into account things like schema evolution. So in those cases, like you're mentioning, our take now is that it doesn't make sense to reproduce that work in the interchange format, but instead to sort of judiciously choose to what level to break down to protocol specified encodings and use those going forward because we know that, full nodes and wallets will have to be able to handle those encodings indefinitely just to cope with data that's coming from the chain. And so those are reliable going forward.
So what has your experience been as far as DC bore and the envelope format itself? I mean, what is when we're pulling it all together,
So,
what
so I do have a comment there. The one thing, so DC bore has been fine. DC bore makes total sense. With the envelope format specifically, um, the one thing that I ran into was that if if a data type is effectively a tuple, it's a product, right? Type, um, and it doesn't have uh, a stable identifier that can be assigned to it that could be used as the key in or the subject, I guess, in the envelope encoding. Um, that has been, that was something that I stumbled over and, Wolf and I discussed it and came to the conclusion that, oh, well, maybe in this case, the unit type is the subject. But that, and then you determine what, then the annotations, whatnot, give you additional type information that's relevant to decoding it. But that sort of subject predicate object association, it assumes a subject that exists only sometimes. So I think that using the unit type as the subject, um, that probably works fine, and maybe that's just the correct answer going forward. And for things like transactions, then the stable protocol encoded TXID is going to be the subject, and for other types that have a sort of sensible unique identifier associated with them, then those types are reasonable subjects. But it's it's a thing that you sort of have to learn to use, or that may raise questions of like, oh, well, what is the correct subject for this type
Yeah.
um, in the
Can I
encoding?
speak to that for a moment as well? So the uh, this conversation that I've been having with Chris is actually, he mentioned the unit type and object, which is essentially a concept from Rust and category theory that is basically an object that conveys no information by itself. And this turns out to be useful in cases where, because envelope basically uses a subject and a set of predicate object pairs, which make assertions about that subject. What if the object itself, the subject itself, carries no information and is entirely defined by its assertions? And that was something that I was basically using, a couple different techniques, either picking a field that seemed to be unique enough or generating a unique identifier, even though one was not really necessary. And then when Chris raised this, I realized this was kind of a gap in our semantic model, and realized that the unit object and type would be a perfect subject for envelopes that the subject carries no information. Which basically means the assertions carry all the information. And that's, I think that's a good solution. The other solution is to simply use, for example, if you need a tuple type, is simply define a Decibor array, where each position in the array is one of your objects, and that's essentially a tuple type. And you don't need, the point is that every leaf of a Gordian envelope is itself a Decibor object. And so it's all Decibor in the end. Even though the Gordian envelope type arranges those things in a tree. So you always have that option of easily defining a Decibor type and using that to represent a tuple or something else. And the subject predicate object is very useful for certain things, knowledge representation, especially when you're making like assertions on assertions and have rich metadata. Other times it's really not necessary at all. And that's provided more easily by ultimately using Decibor.
Yeah. Yeah, the sort of DC-bor, the lines for DC-bor are also interesting. So, we experienced with the QR, UR, PSBT standard that, we did not want to convert the descriptors into fully described Decibor. And the reason why was, descriptors are evolving fairly fast. And so, since we first started doing this, we've had at least 5 new, minor deviations in the descriptor format, and there's some major ones coming up as well. But we also did run into a problem where we needed the public key that was in the descriptor to be able to be referred to outside of the descriptor. And so we basically, have I'm not sure what the right language is for it, but we have it's the descriptor format, but we have the ability to have these kind of placeholders for the public keys, so you can
A
put
hybrid structure, I would say.
yeah, it's a hybrid structure. And those are tough choices. Ken might be able to speak to some other places about that. But where are the lines of we're keeping it in the original structure versus beginning to convert it to CBOR. Chris, go ahead.
Yeah, I think that the overall feedback here is that what's almost needed is like a data modeling best practices FAQ or something like that. So, given the kinds of data modeling issues that people will be coming in with from whatever their source, their source conceptual type system is, let's call it, how to then map those things into DCBOR and the envelope format is, because you've got so much flexibility, you sort of need a best practices,
Yeah,
document or
Chris,
something.
let me speak to that as well, because I've been thinking a lot about this and a lot about kind of disseminating what we've been learning, as well as kind of helping people kind of raise people's general understanding. Into that effort, I've begun a project through Blockchain Commons which you can find right now at cborbook.com, which is leads to an ebook that's a work in progress, but it's certainly useful right now. But basically it's called the CBOR, DCBOR, and Gordian envelope book. The first section deals with CBOR itself, helping people understand what CBOR is and why it's important, even before we go on and add deterministic encoding using DCBOR. And then the third section, which is still yet to be written, will be on Gordian envelope, being entirely both a primer, a tutorial, as well as a section of best practices. So, and I'll be adding a section of best practices. So the actual part one, which is on, I'm sorry, part two, which is on DCBOR, is almost complete, but there's a couple more chapters to be added there. And then I'm going to start on the Gordian envelope chapter. But obviously I welcome contributions, corrections, and suggestions from the community. And I think that, your voice saying, let's have a catalog of best practices and patterns, I think would be an excellent addition to that, because we are learning things as we go. Because when I designed Gordian envelope, I designed it to be very minimalist yet powerful, because of the ways, its basic cases combine. And so, yeah, there's a lot of ways to skin that cat. And if you're trying to say, well, we want to be deterministic, especially in cases that require it, like consensus algorithms, you want to have a sense that you're going down well-trodden paths. And but because Gordian envelope is fairly new, we're still learning exactly what some of those best practices are. So as people discover those things, and so on, we want to have that discussion. And I think this book is going to end up being kind of the repository for a catalog of some of the best practices.
Cool. Ken, sort of at a different layer, I mean, you're dealing with, multi-sig in a lot of cases, which means that, people want oftentimes to have heterogeneity where there's, they want to use your wallet for one of the keys, but they want to use a different key store for a different key, or they're using something like Sparrow as a coordinator, but not actually as a key store. What has been impeding our ability to do that level better? I mean, I've really been surprised that we aren't seeing more from some of the custody companies like Unchained and Casa and the others, because it just feels like, right now it's gotten to be so complex that nobody does it. I mean, Shannon did this report last year that basically said, hey, if you do this in a standardized way rather than, the sort of the NASCAR approach, you eliminate, a huge number of the potential user failures in the UX. Um, Shannon, you might want to pull up that diagram, but I love that little diagram that says, before and after. Here's what happens when you're doing it, in the NASCAR way, and here's a way. But we're not seeing people do that. And do you have any thoughts on that level of interoperability?
Yeah, I think first of all, I think a relatively small number of our customers are actually using multi-sig. It's much more complicated for people to have to get to that level. And I think we only have maybe one or two file formats that we're importing and exporting. So I'd say that we are seeing less of a problem with those formats. And maybe that's okay, but that it's not necessarily CBOR based, but it seems like for the most part, we have like a one or two formats, I think, that we import and export. And we haven't had anybody coming to us and saying like, oh, you need to support this other format or this other format. So like, we just haven't been getting any requests for any additional improvements in that regard, I'd say. With these like custody companies, it is a little annoying. Like some of them, like, that they have different formats or different key requirements. Like Casa wants like your root descriptor, I think, and like the other ones. It's been a while since I've looked at any of them, like with Unchained and River and stuff, but we just aren't getting any requests for it. I think multisig is too complicated for 99% of the people.
Yeah, we just believe that multi-sig doesn't have to be. I mean, we can just, Shannon, did you find that diagram?
I did. I'm going to see if I can get it called up here.
So
Uh,
we basically are saying, no, it doesn't have to be that difficult. And in fact, it makes you more reliable and more secure. But we, obviously that isn't there, we haven't addressed the supply side.
And just also then having to have multiple devices from different vendors. That's just another whole level of education now that the customer has to go through, where they have to learn two different interfaces. And, we just don't get many people that are willing to go that far right now.
Yeah.
yeah. So
Yeah,
this is what Christopher was talking about here. Basically, we wrote up some multi-sig scenarios to describe how would you do this with different devices. And as you just said, Ken, it's very complex. I did this, I think, with a passport, Sparrow, a ledger, and our own Guardian seed tool to have our three seeds and then a coordinator. And we put together this multi-sig scenario, and Chris looked at it and said, yes, that's what's necessary, and no, we're not going to be able to convince people to do it. But a couple years later, after I did that scenario, I did this one, which said, hey, we've got this new envelope system that has GSTP and allows you to do request responses where you actually start automating a lot of the connections between devices. And when you do that, then you suddenly can reduce what we call research points, which are points where a user has to not only make a decision, but they have to figure out what the decision means to almost nothing. And even beyond that, you can reduce the number of times that a user actually has to respond to something by about half. So we think that by increasing interoperability, which is of course what we're talking about today, we can increase automation. And by increasing automation, we can maybe make these multi-sig scenarios realistic, where I agree they are not right now.
Yeah. And this, of course, also applies to things like recovery scenarios. I mean, we've really never hit quite the critical mass to be able to offer a competitor to Ledger's closed ledger recovery. Um, and instead, I'm seeing people going, oh, well, let's just do ledger recovery, but only for our wallet out there. And, yet another lock-in that we haven't figured out. I'd be curious. I mean, I don't know where Zcash is on some of these types of areas, because you don't have a quite the same multi-sig type of architecture.
Well,
Uh,
we have two different multi-sig architectures. We
okay,
have the Bitcoin style transparent Bitcoin script multi-sig, and then we have the nascent Frost
right.
shielded multi-sig.
Yeah, we've been hosting some workshops on Frost to try to address some of the interoperability needs, both at the library cryptography level, but also at the library to application level of Frost, because there are definitely some complications there, because again, you're talking about multi-parties. And we really feel like there isn't really, better solutions for some of the, these UX problems that Shannon was just talking about, other than being able to have, interoperable request responses in some kind of standardized way. So we're hoping that this will be in this year and next, an emerging demand, so that we can really do this. I mean, we're not a standards organization, we're a specification organization. But, we do, in order to stay focused, we don't, really begin work on things until there are two kind of independent parties that want to interoperate. Um, so that's been, one of the key things is, okay, that's a wonderful idea that you would like to write a spec for this particular thing. But, if you want Blockchain Commons to be involved in this, there needs to be at least two of you. And that was one of the things that was really nice working with the Zcash community grants, was that we had multiple wallet vendors basically going, yeah, we really gotta, we need to support this. And so that immediately meant, this was something that was worth putting the effort into. So I think that getting it to at least 2 people to, is one of the challenges. Independent people. Dorian or Zankas or Mike, any thoughts? And okay, well, we're getting on. Ken, do you have any closing thoughts on your where you would like to see partners and interoperability demands in the next 12 to 18 months that you would like to see uh, you know people work with you on?
Yeah, just the wallet interop, I think, is the biggest one. So essentially what you did for Zcash, I'd love to see the similar sort of thing for Bitcoin. But getting the adoption from all the third-party wallets is obviously going to be important. Otherwise, we just end up as another XKCD cartoon
Yeah.
with yet another standard. So
Chris, obviously we've still got more to do to have true interoperability on the Zcash side. But when you look beyond, so when we basically say, yeah, that diagram works, we can migrate between these different wallets at the Zcash level. Do you have as somebody who's kind of looking at the future of Zcash next year? What's after that we might be able to help with?
That's a tough question. I can't see that far in the future. I mean, there's there's a lot coming, and how that interacts with stuff from the Gordian folks, haven't thought about it at all. But
Okay. I mean, the 3 places, obviously, as you begin to do more with Frost, we've kind of architected our tool from the beginning to be multi-sig capable, and really, we've done some diagrams and other stuff about Musig 2 and Frost and all, how these might all work. So you haven't really been exposed to GSTP, but I would encourage you to take a look at it. Because it was really designed for those types of interactions. And then, of course, there's the whole side of, how do I recover? We have an innate ability to do SSKR envelopes so that, you can elide information you don't necessarily want to store long term, but those things for reliability that you do want to keep, you can then shard and store on multiple servers. We would love to have we've been talking with a variety of organizations to host these servers around the world, these shard servers, and we'd love to have somebody from the Zcash community also host one. So that's another kind of opportunity space. And yeah, so we'd love to see that. Obviously, on the identity wallet side, there's a lot of people are kind of going, yes, self-sovereign identity, yes. But self-sovereign identity principle number 6 is portability. And I'm not seeing any portability in any of the identity wallets that are out there. And we're seeing there's I think over half a dozen states are now supporting Apple's wallet. More states are supporting Google's wallet, and then there's the UDI work in Europe. And I'm not seeing any kind of thing. How do you make this portable, reliable, robust in an interoperable fashion. So we're looking for ways to begin to lever into there. Okay. Any last comments from folk? Mike, Dorian, or Zancas? Ken?
Presentation, thank you.
Thank you, Mike.
Yeah, thank you.
Thank you,
Okay,
Mike.
well, thank you very much. And next month, we're going to be talking about provenance marks. This is an emerging approach to have integrity over time. Kind of can think of it as kind of a personal time chain. And just using hash algorithms. It's not a consensus chain. It's more for integrity and provenance. But we've got a nice system that works with the Gordian tools and the Gordian stack if this is something that you'd like to see. So that'll be next month's meeting. And if you have other topics or want to present about your technology in an upcoming Gordian meeting, let me know.